Okay, question 14. The curve C in the standard Cartesian plane is defined by the equation x equal to 4 sine 2y, and then y is in between negative pi over 4 to positive pi over 4. And then curve C passes through the origin O. Find the value of dy over dx at the origin. So for this one, they already have x as a subject, so we don't need to make y as a subject. We can just differentiate x with respect to y. So if x equal to 4 sine 2y, then dx over dy should be 4 times by the derivative of sine 2y would be sine differentiate to cos, we'll get cos 2y. And we need to times by the derivative of 2y, which is 2. So we have dx over dy equal to 8 cos 2y. So then dy over dx is just 1 over 8 cos 2y. And then we know the origin is when x equal to 0, y equal to 0. So if we substitute in, dy over dx is just equal to 1 over 8, because cos 0 is equal to 1. So that would be the final answer for part A. And then part B. So BI, use the small angle approximation for sine 2y to find an equation linking x and y for points close to the origin. So if the point is close to the origin, so it's very small, so we can use the small angle approximation to approximate sine 2y. So x is equal to 4 sine 2y. And then if it's very, very small, so sine 2y should close to 2y, because small angle approximation is just sine theta is approximated to theta if the angle is very small. So sine 2y would just be 2y. So then x is equal to 8y. So that would be the equation linking x and y when the point is close to the origin. And then for II, so this is a straight line. If we rearrange that, y is just equal to 1 over 8 times x. So clearly the gradient is equal to 1 over 8, which is the same as the previous one. So they have the same gradient. That's all. That's the relationship between them. And then part C, show that for all points x, y lies lying on C, dy over dx is in that form. So basically what they want is just, they want us to rearrange the result we get from before, 1 over 8 cos 2y, but they don't want y anymore. They just want us to write in terms of x. So, which means we need to find a way to change cos 2y into sine 2y. That's how we write in terms of x. So there's an identity can link cos 2y and sine 2y. And that identity is very simple. So cos square 2y plus sine square 2y is equal to 1. So that means cos square 2y equal to 1 minus sine square 2y. So if you square root it, cos 2y just square root of 1 minus sine square 2. That's how we change one to the other. So that would be 1 over 8 times by cos 2y, which is same as square root of 1 minus sine square 2y. And then we already know sine 2y is just x over 4 if we rearrange that. So we can put that in, then we can get x. So that would be 1 over 8 times by square root of 1 minus sine 2y is x over 4, and then squared. So simplify it from here, we have 1 over 8 times by square root of 1 minus x squared over 16. So since the final answer, the coefficient of x squared is 1, so they don't want that as 1 over 16. So we need to factorize 1 over 16. So that would be square root of 1 over 16 inside the brackets, 16 minus x squared. So when you factorize out something, you just divide by that number. So 1 divided by 1 over 16 give us 16. And then if you factorize out 1 over 16 from the second term, it's just x squared left. So now, if we keep simplifying, we can change that into 8 times y root 1 over 16, that's just 1/4. And then root 16 minus x squared, that's just the same thing. We can't really do anything. But that can be simplified to 8 times 1/4 is 2. So that would be 1 over 2 times by square root of 16 minus x squared, which is our final answer. So A should be 2 and B should be 16.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.